हॅलो
सर लांब बसायला लागणार ते इक्वल ना सर कमीत कमी 10-15 फूट लांब बसायला सगळ्यांना
शेशी बरोबर
सर
हा
पाहुण्यांची नावं तेवढी सांगा की.
पाहुण्यांची
हा
1 मिनिट
कार्यक्रम पत्रिका दिली असती तर बरं झालं.
व्हॉट्सअपला पाठवू का?
चालतंय की पाठवतो.
1 2 3 4 वेगळे मोरे सर आत लोक जॉईन झाल्यानंतर आत घ्यायचं काय नॉर्मल ठेवलंय का? हा
कॉन्फरन्सच्या पत्रिकेची मारल्या काय झेरॉक्स एखादी?
मारायला पाहिजे. आता काढली प्रिंट सर, तुम्हाला व्हॉट्सअपला पाठवू का?
व्हॉट्सअपला काय होतं हे तर ते मग बंद पडते. प्रत्येक जण मागणार ते.
पोरे सर, हॅलो.
हा सर बोला की. हॅलो.
आवाज येतोय ना?
हा येतोय येतोय सर.
बर बर. किती अजून एक 10 मिनिट. हा
आपण 10 ते 10:15 जॉईनिंगचं टायमिंग ठेवलंय. आताशी 53 जॉईन झालेत सर.
बर बर. हो द्या हो द्या हो द्या.
15 मिनिटांमध्ये जॉईन होतील.
हा चालेल. ओके सर.
हा
ओके.
ओके.
तीन पानाच्या कुणालाही न दाखवता झेरॉक्स मारून आणायचे. वन साइडेडच आहे. 3 झेरॉक्स मारून आण. हा
Sir, all participants look at.
Good morning, everybody. All participants are requested to mute their mic. So within 5 minutes, we will start our inauguration function. Meanwhile, unwanted comments are listening, everybody. So I request you to mute your mic system.
ही करा की जॉईन हो की. बोला की. हे झालं कर कर. आता झाले, सुरू झाले. जॉईन व्हा. Okay.
कार्यक्रम आपल्याला सगळे ऐकू येते यात्रेच्या गणपतीच्या दुर्गादेवीच्या सगळ्या मंडपांचा आवाज ऐकू येतो.
Hello, again I request within 2 minutes this conference will start. So all the participants are requested to unwanted sound is coming. So please stop. It is disturbing. Now it is 10:50. Please stop unwanted sound. It is disturbing. Every participant is online. So now I request to compare to start the national conference. Take the charge and start the comparing.
First of all, salute to the memory of late Honorable Dr. Patangarav Kadam Sahib, the founder of Bharati Vidyapit. A very good morning to one and all respected delegates. It's my pleasant duty to offer you all a very cordial welcome in today's online national conference. भारती विद्यापीठ मातोश्री बायाबाई श्रीपतराव कदम कन्या महाविद्यालय कडेगांव, the Department of Physics, Chemistry and Internal Quality Assurance Cell jointly organized online national conference on applications of advanced physics and chemistry for development of science. Respected all the participants, we will start online national conference with the Bharati Vidyapit welcome song.
काय झालं? दूध आणले.
सहकार्याचे सत्कार्याचे प्रतीक येथे आहे. सहकार्याचे सत्कार्याचे प्रतीक येथे आहे. या देशाचे विद्याभूषण ज्ञानपीठ आहे. या देशाचे विद्याभूषण ज्ञानपीठ आहे. ज्ञानपीठ आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. शिल्प हे स्वप्न आभाळाचे. शिल्प हे स्वप्न आभाळाचे. पावन मंदिर आहे. पावन मंदिर आहे. पावन मंदिर आहे. पावन मंदिर आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. वादळातून झेप घेतली ध्येय पतंगाने. तुफानाशी झुंज घेतली गुणी आनंदाने. वादळातून झेप घेतली ध्येय पतंगाने. तुफानाशी झुंज घेतली गुणी आनंदाने. यशवंताचे यशोगीत हे मूर्तिमंत गाणे. यशवंताचे यशोगीत हे मूर्तिमंत गाणे. निर्धाराची निश्चल निष्ठा. निर्धाराची निश्चल निष्ठा त्याग मागते आहे. त्याग मागते आहे. त्याग मागते आहे. त्याग मागते आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. भारतीय विद्यापीठ आहे. सह्यागिरीची पर्वत आमचा साथी आज भारती विद्यापीठ आहे भारती विद्यापीठ आहे भारती विद्यापीठ आहे सहकार्याचे सत्कार्याचे सत्कार्याचे प्रतीक येथे आहे सहकार्याचे सत्कार्याचे प्रतीक येथे आहे या देशाचे विद्याभूषण ज्ञानपीठ आहे या देशाचे विद्याभूषण ज्ञानपीठ आहे ज्ञानपीठ आहे भारती विद्यापीठ आहे भारती विद्यापीठ आहे भारती विद्यापीठ आहे भारती विद्यापीठ आहे
Thank you. Now we are going to start inauguration ceremony of today's national conference. I would like to request for welcome speech to Honorable Honorable Professor Dr. S.V. Pore sir, ex-chairman BOS in chemistry, Shivaji University, Kolhapur. Members, BOS in chemistry and chemical engineering, Shivaji University, Kolhapur. Members, Faculty of Science and Technology, Shivaji University, Kolhapur. Members, Standing Committee, Shivaji University, Kolhapur. IQAC Coordinator and Head Department of Chemistry of our college.
Okay. Thank you. Good morning to all of you. भारती विद्यापीठ मातोश्री बयाबाई श्री पत्राव कदम कन्या महाविद्यालय कडेगाव is organizing one day online national conference on applications of advanced physics and chemistry for the development of science. So in the beginning, I warmly welcome all the participants. Just a minute, okay. All the participants are requested to mute their mic. Unwanted sound is coming. Please don't disturb. Hello, all the participants, please stop your mic. ज्यांचा माईक चालू आहे त्यांना इंग्लिश मध्ये समजत नसेल तर कृपया मराठी मध्ये सांगतो. माईक कॉन्फरन्स मध्ये एकतर बाहेर व्हा. प्लीज स्टॉप युअर माईक. ओके. Thank you for listening the suggestions and stopping the disturbances of this conference. So in the beginning, the patrons of our Bharati Vidyapit and the conference, Honorable Founder of our parent institute, Bharati Vidyapit Pune, Honorable Patangrauji Kadam Sahib, Honorable State Minister, Social Justice, Food, Civil Supply and Consumer Protection, Minorities Development, Marathi Bhasha, Minister of Legislative Assembly of Police Kadegaon Constituency, Secretary of Bharati Vidyapit Pune, Honorable Dr. Vishwajit Kadam Sahib, Honorable Chancellor of Bharati Vidyapit deemed to be University, Professor Dr. Shivajirao Kadam sir, Honorable Chairman, Bharati Vidyapit School Committee, Vijayamala Kadam तथा वैनी साहिबा, Honorable Regional Director of Bharati Vidyapit Divisional Office Sangli, Principal Dr. H.M. Kadam sir, Honorable Joint Secretary Dr. K.D. Jadhav sir and Dr. M.S. Sagre sir, Honorable Vice Chancellor of Bharati Vidyapit deemed to be University, Professor Dr. Manikrao Salunke sir, respected Principal Professor Dr. Kadam sir, Chairman of this conference, Vice Principal and Vice Chairman of this conference, Professor Dr. Salunke sir. Today, Chief Guest of Inauguration Function, of this national conference, Principal Dr. Rajmane sir from HM College Karad, who will deliver a very informative keynote address in this inauguration function. Then resource person of the session first, senior professor in chemistry, physical chemistry, and recently taken the charge of chairman of board of studies in chemistry of Shivaji University Kolhapur. The resource person from second session, Professor Dr. The session first, Professor Dr. Kodekar sir, who will talk on the innovative topic, fluorescent applications. Then a second resource person of the second session, Assistant Professor in Physics from Department of Physics, Vivekanand College, Kolhapur, who will take on a very advanced topic of the physics. Member of all organizing committee of our college, all the member of internal quality assurance cell of our college, heads of the department and their colleagues, all the participants from all over India, and all my student friends. It gives me an immense pleasure to heartily welcome you in this national online conference on applications of advanced physics and chemistry for the development of science, organized jointly by our Department of Physics and Chemistry and Internal Quality Assurance Cell of the college. Bharati Vidyapeeth is committed to the cause of nation building and involved itself into activities that produce trained manpower required for developing India into a strong nation. Agreeably, India should try to reach the higher pinnacle of economic development by using the advanced technology. However, it is also necessary for us to educate our students on the negative side effect of uncontrolled use of modern technology. It has numerous implications that needs to be brought to the attention of not only the people of this generation, but also the next generation. It is necessary to give training to our students, teachers, to make use of technology without disturbing the nature. The topics selected for the conference are of modern need to create eco-friendly environment by strictly following 12 principles of green chemistry and to minimize the problems created due to excess use of modern technology in every field of developing science. So, which actually the use of modern technology in every branch of the science, and it is a serious problem growing steadily worse today. Nowadays, the green chemistry supports nature ecosystem and conserve ecological balance. The progress of the nation is principally governed by suitable utilization, conservation, and management of bioresources. As per the motto of our Bharati Vidyapeeth, parent institute Bharati Vidyapeeth, social transformation through dynamic education, our college provides platform to educational, social, cultural activities for awareness opportunity to the needy among the society. This conference is also no exception to these routine activities of the Bharati Vidyapeeth. The Department of Physics and Chemistry, Botany, Zoology, Microbiology, and all other departments from Arts and Commerce faculty are biggest of its kind in our college, and all departments are flourished by undertaking different activities, workshop, seminar, conferences, group discussion, industrial visit, consultancy service, career-oriented courses, skill-based courses, value-added courses, research projects with high result profile of all the classes every year from its establishment, which is reflected in progression of the student in higher education and placement of the alumni, which is required by the NAC for their inspection. I am confident that this conference will provide the platform for the invited speakers, eminent researchers, young scholars, and students, And also this conference will excite all the participants to discuss and make awareness at individual, national level for fruitful deliberations to propose new ideas. We have overwhelming response of all the participants for their registration as well as joining of this conference. In addition to that, those who will found any trouble, they will join on YouTube also. This conference will be streamed on YouTube also. Again, I extend a very warm welcome to you all, chief guest, resource persons, delegate, participant of this conference, and wish the conference a grand success on behalf of organizing committee of our college. Thank you. Thank you very much.
Thank you very much, sir, for your great welcome speech. Now I request to chief guest of today's inauguration function.
Introduction.
Sorry. Now I would like to request Professor Dr. Pore sir for the introduction of today's chief guest of our conference. Professor Pore sir.
Okay. Today, in this online conference, we are very lucky to have a chief guest who is very active in administration of the college, research in the subject of chemistry, and he had committed so many activities as a social commitment in his daily routine. Dr. Rajmane sir, Principal, HM College, Karad. I would like to introduce shortly. He had completed his PhD, MSc, and BSc from Shivaji University, Kolhapur. He had 30 years of teaching experience. Administrative experience is 18 years. He had completed 1 year as a head department of ASC College, Malkapur. Then he had continued his administrative work as a principal from ASC College, Ramanand Nagar, and presently he is working as a principal at Sadhguru Gadge Maharaj College, Karad. As an administration, he is also a good researcher. He had completed his PhD and he had good publications in journal of well-reputed, UGC listed, which are data indexed in Scopus. To total 12 publications are there. Then he had published 7 books which are very, very helpful for the students of BSc from the subject of chemistry itself. Then he had guided one successfully student for PhD. One is working under his able guidance at HM College, Karad. He was a Senate member of Shivaji University, Kolhapur from the period of 2011 to 2016. He is awarded by Karad Gaurav Puraskar by PD Patil Pratishthan, Karad, and also so many awards are on his record. In addition to that, this paperwork, he is a very good philosopher, administrator, researcher. So with this, I request the chief guest of our today's inauguration function, Dr. M.M. Rajmane sir, to deliver his informative keynote address. Thank you. Thank you very much.
Thank you, sir. Now I request to chief guest of today's inauguration function, Honorable Principal Dr. M.M. Rajmane sir, Sadhguru Gadge Maharaj College, Autonomous, Karad, District, Satara. Principal Dr. M.M. Rajmane sir.
Thank you, Pore sir.
Hello.
Good morning.
Good morning, sir. Okay.
Very good morning.
Good morning.
Honorable Principal Dr. H.M. Kadam sir, Regional Director, Bharati Vidyapit, Pune. Principal Dr. V.Y. Kadam sir, इंचार्ज प्रिंसिपल मातोश्री बयाबाई श्रीपतराव कदम, कन्या महाविद्यालय कडेगाव, my friend Professor Dr. G.B. Kolekar sir, Chairman BOS in Chemistry, Shivaji University Kolhapur, Dr. Sanjay Latte sir, Department of Physics, Vivekananda College Kolhapur, my friend Professor Dr. S.V. Pore sir, Head Department of Chemistry and Coordinator IQAC, Dr. U.K. Mohite sir, from Department of Physics, all the faculty members, participants, student friends. First of all, I congratulate all the faculty members of Physics and Chemistry, as well as IQAC cell of this college for organizing such national conference, important subject, that is applications of advanced physics and chemistry for development of science. I am very much thankful to this college for inviting me as a chief guest for this national conference. Friends, I am honored to share my views on applications of physics as well as chemistry in the development of science. Physics and chemistry are the subjects that are complementary to one another. If we apply both the subjects simultaneously, we can achieve a lot of things in development of science and technology. Simultaneously, we can achieve a lot of things. Physics and chemistry are the two subjects that have enormous potential to offer a lot of things on this world. Both subjects have contributed immensely of science as well as the technology community. Contemporary research field of material science, which is a nanotechnology, and nanotechnology is a mixture of chemistry and physics. Material science drives innovations in research as well as in industries, everything from aerospace to medicine. All world is literally running after the material science research. Researchers from all over the world are applying chemistry as well as physics together for development of material science. As we know, quantum mechanics is another branch of physics as well as chemistry that explain most of the physics and all of chemistry. Physical chemistry is another branch that concept of both physics as well as chemistry. Chemistry is essential, as we know, for meeting our basic needs. Which are our basic needs? Such as food, clothing, shelter, health, energy, clean air, clean water, and soil. Chemical technology enrich our quality of life in numerous ways, providing new solutions to problems in health, to problems in materials and energy also. Chemicals are the fundamental components, as we know. Chemical molecules make up all foods, including carbohydrates, vitamins, lipids, proteins, and fiber, which all are safe and often desirable. Chemistry, for example, explains aspects of plant chemistry, that is botany, the formation of rocks, that is geology, how atmosphere ozone is formed, and how environmental pollutants are degraded, that is ecology, properties of lunar soil, that is cosmochemistry, and how medicines works, pharmacology, and others. Friends, as we know that physics helps us to organize the universe. It deals with the fundamentals and help us to see a connection between seemingly disparate phenomena. Physics gives us powerful tools to help us to express our creativity, to see the world in new ways, and then to change it. Physics is one of the most elementary science that contributes directly to the development of science as well as the development of new technologies. Physics studies everything that takes place in the universe, including particles, natural phenomena, as well as energy and their interrelationship with one another. Physics is characterized by precision, which motivates scientists always to invent new tools as well as methods that take care of the accuracy and result of physical experiments. Friends, the theme of today's conference is really multidisciplinary, that it has the potential to have a significant societal influence. The conference provides a shared platform for young researchers to communicate as well as to exchange ideas with the professionals and experienced scientists and debate new trends in chemical as well as physical sciences which are emerging. The committee has organized a vibrant scientific program and arranged lectures of internationally reputed speakers to lead it. I wish you a very productive conference with exciting and encouraging discussions and exchange of knowledge so that together we can anticipate the future ground-breaking knowledge, research, and technology for humanities. I wish you all the best for this national conference. Thank you very much.
Thank you for your great guidance. Now, I would like to request for presidential address, Professor Dr. Vivai Kadam sir, in charge principal and head of the Department of Zoology, Professor Dr. Vivai Kadam sir. Sir, तुमचा टाइम झाला. सुरू झालं. Wait for only 1 minute. Due to the
We continue. The presidential address will start. So meanwhile, the chief guest of this inauguration function have given an overall development of the physics, chemistry, chemical, biological, life science from the perspective of overall development of the human beings, life requirement, and how the human being life is made easy by the modern technology. But in our session first and session second, we will come to know that the latest and recent technologies which are highly applicable and worldwide, and with this, all the researchers participants will work the research.
Hello. Hello, sir.
Okay, thank you. So
Am I audible?
yes,
ऐकू येते, sir?
You are ready.
Ah.
Okay.
Yes, sir.
So I request the Honorable Principal of our college for his presidential address. Professor Dr. Kadam, sir.
Very good morning to everyone. On the occasion of inaugural function of online national conference on application of advanced physics and chemistry for development of science, I welcome Honorable Dr. Vishwajit Kadam Saheb, Secretary and Pro Vice Chancellor Bharati Vidyapit Pune, Professor Dr. Shivajirao Kadam Sir, Chancellor of the Bharati Vidyapit Deemed University Pune, Honorable Vijay Kadam Vahini Saheb, Chairman School Committee Bharati Vidyapit Pune, Principal Dr. K.D. Jadhav Sir, Joint Secretary Bharati Vidyapit, Principal M.S. Sagre Sir, Joint Secretary Bharati Vidyapit Pune, Dr. H.M. Kadam, Regional Director Bharati Vidyapit Pune. I welcome Chief Guest of National Conference, Dynamic Principal of SGM College, Dr. Mohan Rajmani Sir. I also welcome resource persons, Professor Dr. G.B. Kolekar Sir, Chairman BOS in Chemistry Department, Shivaji University, Kolhapur, Dr. Sanjay S. Latne, Department of Physics, Vivekanand College, Kolhapur, Coordinator of this conference, Amal More Sir, Convener of this conference, Dr. C. Patil, Head of the Chemistry Department, Professor Dr. Sanjay Pore Sir, Head of the Department of Physics, Dr. U.K. Mohite Sir, members of the organizing committee and my colleagues. Dr. Patangraji Kadam laid the foundation of Bharati Vidyapit on 10th May 1964 with the motto, Social Transformation through Dynamic Education. Our educational campuses at Kadegaon, Sangli, Karad, Panchgani, Solapur, New Mumbai, New Delhi, Pune, and beyond the boundaries of the nation at Dubai and US, have been imparting quality education to students for better tomorrow in building the nation. Honorable Dr. Vishwajit Kadam Saheb, a dynamic youth leader, is a governing parent institute, Bharati Vidyapit, Danga Kami Kara, Bharati Vidyapit, as a secretary and pro vice chancellor. The institution is heading under the able guidance of Chancellor Dr. Shivajirao Kadam Sir and Honorable Vijay Tatha Vahini Saheb, Chairman School Committee Bharati Vidyapit. Our college has a milestone in development of rural girl students since 1990. The college has been accredited A grade by NAC. We are proud to mention that our NSS unit awarded the most prestigious Indira Gandhi Award, National Award. The students of our college have secured top positions in order of merit in the university examinations and have brought number of medals by participating in number of events such as Avishkar, sports, cultural activities of university, state and national level. Physics, today's conference is on application of advanced physics and chemistry for development of science. Physics improves our life by providing the basic understanding necessary for developing new instrumentation and techniques for medical application, such as computer tomography, magnetic resonance, हॅलो पोरे सर, हॅलो, अरे आवाज बंद करा.
हॅलो सर,
नाही ते लेफ्ट व्हा.
फोन केलाय, त्यांना बोलवून घेतलंय, त्यांना फोन बंद करायला सांगितलं.
त्याला लेफ्ट करा त्याला.
हा, हॅलो सर.
मॅग्नेटिक रेझोनन्स इमेजिंग,
अरे ज्योती
पॉझिट्रॉन
सुतार
इमेजिंग,
बोलतोय. ज्योती सुतार,
टोमोग्राफी.
आपला माईक बंद करावा. सगळ्या कॉन्फरन्सला डिस्टर्ब व्हायला लागलेला आहे. आवाज गेला काय? आवाज येणार तुम्हाला येतो का?
आवाज येतोय का?
आता यायला लागला सर. यायला लागला सर, कंटिन्यू करा.
Okay, sir. Physics is a branch of science that deals with structure of matter and how fundamental constituents of the universe integral. It studies objects ranging from very small using quantum mechanics to the entire universe using relativity. Contribution in the development of science. Using electron microscope, we can observe the structure of the cell and structure of microorganisms. Radioisotope for the radiation treatment and treatment of cancer and other diseases. X-ray and neutron diffraction techniques for studying structure of nucleic acids, which control the process of our life activities. Physics provides possibility to help biology further in discoveries such as with molecular physics, which helps genetics and antibodies. Physics is all over inclusive of science and has had a profound effect on all scientific development. In fact, physics, the present day equivalent of what we used to be called natural philosophy, from which most of the modern science arose. Advanced physics made contribution in ultrasound diagnosis, hyperthermia, radiology, ophthalmology, endocrinology, physiology, physical therapy, and general medical instrumentation. Laser scalpels figure prominently as powerful tool in many surgical procedures. Next, chemistry is often referred as the central science because it joins together physics and mathematics, biology and medicine, and earth and environmental sciences. Knowledge of chemistry provides insight into the variety of physical and biological phenomena. Chemical research and development contribute to energy efficient LEDs, solar cells, electric vehicle, batteries, water desalination, biodiagnosticism, advanced material for durable clothing, aerospace, defense, agriculture, nanotechnology, as well as health and medicine. Chemical reactions help us to understand the properties of matter. By studying the way a sample interacts with other matter, we can learn its chemical properties. These properties can be used to identify an unknown specimen or to predict how difficult types of matter might react with each other. Chemistry finds many applications in the healthcare fields. Development of medicines involves many complicated chemistry processes. Chemistry is used to create materials used in surgery. Much of the laboratory testing is based on chemistry techniques. Industrial application of chemistry directly affect daily lives. What we eat, what we wear, our transport, the technology we use, how we treat illness, and how we get electricity. Life is a grand combination of physics, matter and energy, and chemistry, matter, energy, and interactions. In an ordered way, that is, electron in physics and sharing of electron between atoms is chemistry. Use and study of these processes as applicable to life are biophysics and biochemistry. With this, I conclude my speech. Thank you, sir. Thank you very much. Over to Amal More, sir.
Thank you, sir, for your great guidance. Now I would like to request Professor Dr. V.S. Saranke, sir, Vice Principal of our college and convener of the Criteria 5, Infrastructure and Learning Resource, to express the great gratitude of the inauguration ceremony. Professor Dr. V.S. Saranke, sir.
Hello. Hello.
Yes, sir.
Hello.
Am I audible?
Audible.
Yes.
Please share your screen.
Yes, yes, sir. Yes. Continue, sir.
Today's inaugural function of the coordination with physics and chemistry, and also the AQR has organized this national conference, and this national conference, the inaugural function, vote of thanks, is respected dignitaries on the dais and off the dais. It is a great honor to purpose the vote of thanks at the end of the inaugural function sponsored by the physics, chemistry, and AQR one-day national conference on this unit. First of all, I would propose a special vote thanks to today's chief guest, Honorable Dr. Rajmane sir. He is the principal of HM College, Karad, and the member of Rayat Shikshan Sanstha. In spite of his busy schedule, he prior a commitment as assiduous absence and encouragement to the all delegates. Sir, your guidance is helpful us in near future. Thank you. Secondly, I will propose a vote of thanks, our college principal, Dr. V.Y. Kadam. He's giving the information about the Bharati Vidyapit and valuable guidance on the physics, chemistry, and AQR. Also, I am thankful to Dr. V.Y. Kadam shared his views on this conference. Then I would thankful to vote of thanks to Dr. Pore Yasvi. A special thanks in his valuable guidance, arranging the conference, enlightening with us, and need of the conferences, who has constantly supporting and encouraging us. Thank you, sir. Then next, that is chairman or convener of the conference, Dr. C. Patil, Department of Physics of our college. He is giving this opportunity for students and staffs in various colleges to organize this conference. Lastly, thanks to all faculty members of our department, other faculty members of the non-teaching staff, delegates, resource persons, and chairpersons. Once again, I thank and all being present us this inaugural function. Thank you.
Thank you, sir. Now, in this way, we are going to finish here the inauguration ceremony of today's national conference. Respected all the participants, now we will start the first session of today's national conference. I hand over the charge of session first to the chairman of the session first, Honorable Professor Dr. S.V. Pore, sir.
Good morning, everybody. Very nice guidance from inauguration function. In continuation with the inauguration function, I would like to welcome you all participants in the session first. Today, we have a very innovative personality in the field of physical chemistry, a senior professor of physical chemistry from Shivaji University, Kolhapur, and coordinator of the RUSA, and who had recently taken the charge of Board of Studies in Chemistry and Chemical Engineering, who have completed 2 years in South Korea. Professor Dr. G.B. Kolekar, sir, I will introduce very shortly. He is a fellow of Award of Maharashtra Academy of Science, Maharashtra, ARN visiting scientist, Anyanga University, Seoul, South Korea during May-June 2009 under an Asian Research Network program. INSA visiting fellow, Kimbyu National University, Taegyu, South Korea during September-October 2009 under INSA, India, NRF of South Korea bilateral exchange program. Brain Pool Fellow, Hanyang University, Seoul, South Korea. He had conducted some administrative responsibilities on his shoulder, coordinator of RUSA from 2017 to till date. He is a coordinator of Department of Applied Chemistry, member of Senate, Shivaji University, Kolhapur from the period of 2010 to 2015, member of Board of Studies, Department of Chemistry. Now he is a chairman of Board of Studies in Chemistry, Chief Rector, Hostel, then Rector of Appasai Power, Vidyasri Bhavan, Program Officer of National Service Scheme, Coordinator, Assessment of Gram Panchayat under Nirmal Gram Yojana. Also, he had committed some social responsibilities in coordination with the government. Coordinator, Staff Secretary, Department of Chemistry, Assistant Divisional Controller, Maharashtra Talent Search Examination, Coordinator, Maharashtra Talent Search, Marcirus Tehsil, Chairman, Staff Student Welfare Committee, Department of Chemistry, Shivaji University, Kolhapur. Along with this, he had also shouldered some academic responsibilities, that is visiting professor at Anyang University, Seoul, South Korea in September 2000, December 2014, member of Board of Studies in Koyampi University, Shimoga, member of Board of Examination, Koyampi University, Shimoga, chairman of Board of Examination, Akkamadevi Women's University, Bijapur. Also, he had shouldered a member of Board of Studies in Akkamadevi Women's University, Bijapur. He was a member of Research and Recognition Committee, Solapur University, then examiner, referee for PhD, open defense in so many activities. Then I am much more impressed from this, that is Indian patents. He had filed 5 patents he filed, and he had written 4 books for the students of BSc, MSc, in the subject of physical chemistry itself. Then he is a author of international book Environmental Remediation through Carbon-Based Nanocomposites. Then he had completed so many research projects under UGC and other funding agencies. Then along with this, he had completed so many research activities in Shivaji University, Kolhapur. So I am lucky enough that our Bharati Vidyapeeth, our college, and this conference is very lucky that we have a resource person like this. He will talk on the topic fluorescent applications. So I request Professor Dr. GB Kolekar sir. I again welcome in this conference and request to have interaction with us on the topic of the theme of this national conference. Thank you. Thank you very much.
Thank you, Professor, for kind introduction. So I am very much thankful to college who have given me an opportunity to share my talk on such a wonderful activity, so which is organized by your college. So being a BOS chairman, so I would like to congratulate the college, especially Matosri Bayabai
Sripatrao Kadam
Mahavidyalaya, Kanya Mahavidyalaya, who supported to the department to organize such a national conference, and the physics, chemistry, and other your IQAC. So I have jointly organized such a activity, and so on such a platform, I have an opportunity to share my talk. So whatever I did work in my laboratory, so the fluorescence nanomaterials and their applications, I will share with you. So just wait. Professor.
Yes.
So just to allow to share my PPT.
PPT. Okay, sir. We will wait. All the participants are requested to be online. Meanwhile,
host disabled participants screen sharing. So just
hello, Maurice sir. Just a minute. Just a minute. हाँ त्यांना ते स्क्रीन शेअर करायचं कुठे ते व्हाईट बोर्ड हाँ व्हाईट बोर्ड हाँ यस तिथे येत आहे सर हाँ झालं झालं का सरांचं आलं का your screen sharing is paused हा काय माहिती इथं काय आलं बघा हो स्टॉप शेअर आलं इथं लिव्ह आले काय आलं बघा शेअर शेअर Just a minute. Sure. Kai ko. Just a minute. PPT. Host ka selfie. पार्टिसिपंट कडे जायचं. इथं. वाडा की वर खाली. एक मिनिट खाली कुठे गेलं?
पार्टिसिपंट शेअरिंग स्क्रीन.
बोरे सर पार्टिसिपंट शेअरिंग स्क्रीन आहे ना तिथं अलाव करा.
हा
एनेबल करा तिथे.
हा
तर डिसेबल येते हो.
मल्टिपल पार्टिसिपंट आता आलं का?
नाही ना.
जस्ट मिनिट.
हा हा आता आलं आलं आलं.
ठीक आहे कोळेकर सर केलं हा आले स्क्रीनशॉट घ्यायचे काही रेकॉर्डिंग होते.
So you are visible to this screen?
Yes, sir. Your PPT is visible.
Okay. Now, today I am going to deliver my talk on the topic of fluorescent nanomaterials and their application. So, actually, these fluorescent nanomaterials, so we know that before going to see some research work, so I highlight what is actually the basics of fluorescence spectroscopy. The fluorescence, it is actually a kind of light emission. To understand this fluorescence better, first we should understand that what is luminescence. And luminescence is the emission of light from material, so which are not solely conditioned by rays in temperature. It is just opposed to the incandescence. In incandescence, we have seen in the normal filament bulb in our houses, in our office, so that the light coming from the bulb, it is because of heating. But in contrast to this, in fluorescence, this is not because of heating. So this luminescence, it is termed as cold light. And so this luminescence, we say it is an emission of light. This luminescence, it comes from the word lumen, which is actually Latin word that means light. And it was first introduced by German physicist Wiedemann in 1888. So this luminescence, actually modern way we can tell it is just emission of radiation from excited species which are not in thermal equilibrium with surrounding. So these luminescence, they are categorized in different types which based on the mode of excitation. And these varieties of the luminescence are there: chemiluminescence, bioluminescence, photoluminescence are there. Now I just told the luminescence is the emission of light. Fluorescence, it is also emission of light. And these luminescence, there are varieties, there are various types of the luminescence are there. So these types actually which based on the excitation source, which based on mode of excitation. So just see the first type, chemiluminescence. Chemiluminescence, it is also the emission of light. So bioluminescence, it is also emission of light. All these various types, it is the emission of light from electronically excited state. But the base is the chemiluminescence, actually mode of excitation is chemical reactions. If we take the reaction, suppose for example, luminol react with the hydrogen peroxide, these oxidation reactions. As you have seen glow sticks, where sticks will be broken and it will start glowing. So this is basically chemical reactions which evolves the light. So the glow stick becomes glowing, and this can be performed, usually it is in the dark. So this oxidation may cause for this light emission for this device, and this is called as the chemiluminescence. So simply emission of light cause of chemical reactions, this will give the radiations are there. So similarly here bioluminescence, here also the emission of light is there, the mode of excitation, so that is the actually biological reactions are there. Mode of reaction is biological reactions. We know that this you have seen for the firefly. So this will gives the light. This will firefly gives the radiation. So that is the type of luminescence. That is the emission of lights are there. So like this way, this radioluminescence are there, electroluminescence are there. So electroluminescence means by connecting to the electric field, emissions takes place, emission of light is there. So like this way, it is a one photoluminescence are there. This photoluminescence, mode of excitation is absorption of light. So molecule which absorbs the light, emission observed, emission of radiations are there. This photoluminescence, it is a nothing but fluorescence, and this fluorescence is a special type of luminescence, and which is called as a photoluminescence are there. And here by observing the several types of these luminescence are there, you will come to know that so only it is a emission of lights are there from excited species. So any molecule, any material which absorbs the light, the electron moves to the excited state, ground state to excited state, and from the excited state the emissions of radiations observed, emission takes place, but the mode of excitations are the different. And here our interest is to see the fluorescent material. So actually, so just see the fluorescence, it is explained emission of light by substance that has absorbed light or the electromagnetic radiations are there. I shown you in this diagrammatically S0, S1. So S0, that is actually the substance. It is a molecules are there. By absorbing light, so it goes to the excited state S1. And same these excitations I have shown here, it is just corresponding the excitation spectrum of these absorptions. The molecule absorbs the light by molecule, so it goes to the excited state, and this the absorption spectrum, just it is identical to the excitation spectrum shown by the blue ink. And similarly, once it goes to the excited state, so what happen, this emission of light, emission of radiations or heat, it loses sometimes some takes the period. So then after excited state, these radiations, it come back to the ground state, and it corresponding shows that is actually the emissions are there. So this emission spectrum, it has to be shown in the spectrum. Now we have taken the once molecule or material, once absorbs the light, then it goes to the excited state and several changes, several phenomena occurs. So this fluorophore, actually it is, you will come to know that. So fluorophore means it is simply a fluorescent chemical compound. Those, they can re-emit light upon absorption of light excitations. So some examples I have quoted here: rhodamine, fluorescein, fluorescent nanomaterials are there. So these actually the fluorescence nanomaterials, so quantum dots, carbon-based fluorescence nanomaterials, they are have given. So actually, whatever the works which based upon fluorescent nanomaterials and their applications. So here it is basically the sir. सर आता दिसतंय का पोरे सर? हॅलो पोरे सर,
मी आता तुम्हाला होस्ट करतोय. हा, म्हणजे तुम्ही तिथून आता स्क्रीन ही करू शकता आणि बाकीची अनशेअर्ड बंद करूया. आता नाऊ यू आर ए होस्ट.
आता विजिबल आहे का स्क्रीन?
स्क्रीन विजिबल आहे, परंतु पहिली जी टायटल पीपीटी तुमची आहे
तेच आहे का? बरोबर.
आणि मोठा करा. ओके.
आता दिसते?
व्हेरी नाईस सर. ओके.
बर, आता मी चेंज करतो. आता चेंज केले होते का?
होय बदलतायत सर, बदलतायत.
ओके. Now actually whatever the fluorescent nanomaterials, and we have done some applications, a simple chemistry we implemented in our research laboratory, but all these things, so it is basically to know the Jablonski diagram. So we'll understand this process behind the fluorescence. So actually just use know this part, that is we are having the three singlets are there. So S0, S1, S2, and you may know that so this S0, that is the ground state, and S1, S2, it is a excited state, but it is the first excited state, second excited states are there. When we have a molecules are there, and this molecule initially we have a lot of vibrations. We have a lot of vibration level with in each singlet state, and this electron presents in the lowest vibrational level in ground state molecule. So when it absorbed by the light, they goes excited state either S1 or S2. We can also show S3, S4 and so on, but we are restricted here into only in the S1 and S2 excited state. But when the electron moves to the highest vibrational level, it returns back to lowest lower of the excited state by undergoing some vibrational relaxations. So these vibrational relaxations actually shown by the yellow ring, so that it is what it indicates that, so whatever the light absorbed, it goes to the S0 to S1 and S2 and immediately come back to the lowest level of excited state. So it may having shown by vibrational relaxations are there, and this vibrational relaxation, that here it is not emitting light, it is not emissions of the lights are there, but it loses energy in the form of heat. So that here we call as it is a non-radiative transitions are there. Now, once in case of this, so actually energy level of S2, it is equivalent to, it is equal to any of energy of S1. We have a internal convergence are there. So every internal convergence or vibrational relaxations, this inter-system crossing, once molecule excited, it have a several changes are there, and for these changes they take some times, and for this time they have to be categorized. Either it is an internal conversion, either it is a vibrational, either it is inter-system crossings are there. All these, they are non-radiative transitions because it is after deactivations. So actually they are having a two types of the transitions are there. One, it is a radiative transitions, and another one, it is a non-radiative transitions are there. And those which, so once it come back to the lowest level of excited state, then have a opportunity to come back to the ground state, and that we shown it is by green S1 to S0, that is to be the emission of light, that is the fluorescence are there, that is the fluorescence are there, and it belongs to the radiative transitions are there. So these radiative transitions, it have some time periods are there. So generally 10 raised to minus 6, 10 raised to minus 10 to minus 7, this much time occurs to execute, to produce, to give the emission of radiation, and that is actually the fluorescence are there. And similarly, when this conversion takes place, say S1 to T1, that is the inter-system crossings are there, it goes to the excited triplet state and then come back to the again the lowest level. So that is this S1 to T1 conversion, then internal conversion, vibrational relaxations, all these they are having in a non-radiative transitions are there. They loses energy, they won't give the emission of light. So only excited state to ground state, that emission of light observed occurred, that is actually the emission of light, that is actually the fluorescence, and that we have to study here. Now we know that actually for the study of the spectrophotometer, it is just similar to the colorimeter, spectrophotometers are there. Look at this, just the component. We have light source, the monochromators are there, sample cell, and another detectors are there. Now, this spectrophotometer, just block diagram. When we compare to the spectrophotometer or colorimeter, now in this spectrophotometer, just it is similar to that. So by considering the source part, we take here xenon lamp, and we can also take laser, LED, diodes. So most manufacturers, they use the xenon covers, xenon lamps are there. So once it is installed, so 2000 hours it works. And actually this instrument which we available in my research laboratory. So this xenon covers actually UV visible range 200 to 800 nanometer, but it is a continuous energy. So unlike it is a tungsten deuterium lamp where it is used in the spectrophotometer or colorimeters are there, and this xenon lamp light falls on the sample using excitation monochromator. Here we are using two types of monochromators are there. So that is the excitation monochromator and emission monochromators are there. But we know that it is in spectrophotometer, we use only one monochromator. Why do we require these two monochromator in the spectropolarimeter? Actually, here the excitation monochromator will allows only the chosen wavelength for excitation. And so if we know the molecule will absorb energy between 300 to 400, then we can choose that range only. And so we need not cover the complete range of the wave. And so one by one, we can measure the wavelength will pass through this. And this another thing, we have the samples, so that will absorb all the 100% of the light entering into it. And so after that absorbing light, the remaining light, it will be transferred. And we know that in the spectrophotometer, we have also detector. In spectropolarimeter, we have also detector. But the change is here in spectrophotometer, the detector here is at 180-degree angle from the source, because we used to measure the intensity of transmitted light. And in spectropolarimeter, we are measuring the intensity of emitted light. So this is the actually difference in this is. And so that we are placing the detector at an angle 90-degree from the source. So this is very, very important and change in the spectrophotometer and colorimeter. So it is a straight line, 180 degrees Celsius, 180-degree angle, it is placed the detector, and in spectrophotometer, so 90-degree it is arranged. So these transmitted lights should not interfere with the emitted lights are there. And here, this we have such type of the spectrophotometer component. So because this Jablonski diagram and instrumentation part I have covered, because I think mostly the students, they are attending such a conference, so I have given the change in this. Now, once by understanding this instrumentation part and Jablonski diagram, the characteristics, so we have we know that by measuring with the help of spectrophotometer, this spectrum which will determine absorption spectrum as well as emission spectrums are there. So once molecule excite, that is the absorption spectrum, we also recognize it is excitation ones are there. And then come back excitation to ground state, that is the emissions. And when they takes place overlay, so that is actually from this overlay, we could calculate so many parameters are there, whether it is energy transfer or electron transfer, by observing a spectral overlap in between two spectrum, that we can quote. Also, we calculate the Stokes shifts are there. So these parameters are there. Now, by once choosing the fluorescence study, we have the fluorescence quenching parameter. So quenching means actually decreases the fluorescence intensity of samples are there. And so it is one of the very important parameter photophysical processes, fluorescence quenching. So varieties of the quenching parameters are there: self-quenching, chemical quenching, dynamic quenching, static quenching, so many parameters are there. So what type of the interactions takes place between the donor molecule and acceptor molecule, they will be just characterized it. And by studying this fluorescence quenching, so actually by once it is obeyed, so from this fluorescence quenching mechanism, we can distinguish these varieties of the quenching, and it can also categorized by distinguished by the temperature parameters are there. So once it is obeyed, the fluorescence quenching, we can obtained from the fluorescence quenching mechanism, that is the Stern-Omer equations are there. And so this is just Stern-Omer equations, and Stern-Omer equations, we have the plot F0 by F versus Q. Once the straight line obtained having intercept one, then and then our fluorescence quenching experiment, it is to be valid or obeyed. So it is just similar like to the Lambert's-Beer's law. So it is straight line passing through the origin, then law is verified. Here in fluorescence quenching study, fluorescence sensing study, so once it is a straight line passing through the intercept having a 1, then and then our fluorescence quenching experiment, it is to be valid. Now we have this fluorescent nanometer crystals are there. So these varieties of the colors appears by dissolving different solvents, and we could get to absorb the light and then re-emit light in the different color, and we'll notate the size of the nanocrystal in forms of the angstrom. So we have just shown some of the colors, some of the samples in these tubes are there. So actually just these advantages of these studies, it is actually in comparison with the colorimeter, spectrophotometer, the spectrophotometer, it is a very, very sensitive instrument. Even we can determine 10 raised to minus 10, minus 12, 10 raised to minus 9. So in this range, we can choose, we can determine the concentrations amount. So very sensitive instrument equipment, and these techniques are there and very also easy to operate. So have the varieties of the applications used in the drug detections, protein analysis are there. So just this is the overview of the basics of the fluorescence study. Now, whatever we learn it in this fluorescence spectroscopy, we have carried out the actual work in my laboratory. So some of the topics, some of the paper I just shared here. So semiconductor quantum dots as a fluorescent probe. I have synthesized quantum dots. In the second topic, quantum dots as a fluorescent probe in a sensor technology, and same synthesize the carbon dots used in agriculture field. So how I applied to the society, that I will show some of my work. So just this quantum dots synthesized by the reported method, but with some little modifications are there. And whatever I have synthesized these quantum dots, so it is easy to every researcher has to go for the confirmation. And I have confirmed whatever I synthesized, it is confirmed by first technique easily available in everywhere, laboratory, colorimeter, that is then spectrophotometer, particle size DLS, and then I came to know that so these quantum dots, it is a well reputed and synthesized as per the reported method. And I have done as per just explained you, this is the actually fluorescence quenching studies are there. So before that, the various parameter we have optimized for proposing the fluorescence method for these quantum dots. We have tried the time parameter, then pH, then another things. And once it is proposed method, we have developed. So we have gone for measurement of the fluorescence quenching study, and this fluorescence quenching of cadmium sulfide quantum dots, those which I have synthesized in this same. So these quantum dots by different addition of the rentyl hydrochloride drug. So we just varied this drug in presence of these quantum dots, and we found that so the quenching it is occurs, and it is just linearity. I have checked LOD that we have found. And how will confirm this fluorescence quenching study? So it is just corresponding. I have shown that is to be the Stern-Omer equations are there. And we came to know that, so this fluorescence quenching study, so it is a straight line and passing, so having a intercept 1, and then we can just whatever this quantum dots quenching fluorescence study, we varied with the drug and the Stern-Omer equations, which is obeyed, then our linearity and LOD and all these things parameter, it is just to be calculated and fit to the in order of the met the conditions of the fluorescence quenching studies are there. So whatever we have taken these quantum dots and ranitidine hydrochloride drug, so here we have shown some schematic illustrations example we have just given. So that means simple, it is a mechanism of this quenching I have shown here. So in this one of the spectra I have shown, that is actually the colorimeters absorption spectrums are there. So initially we do not found the absorption maxima for these quantum dots, but addition of these, so it quenches and shows some of these by here in the reaction mechanism I have shown this cadmium sulfide. So so just it absorbed by going to the excitation bands. So here it just indicates that if the fluorescence emission quenching of cadmium sulfide quantum dots so occurred because of only the charge transfer, the absorptions of sufficient light energy, it causes the excitation of electron from the valence bond to the conduction band, resulting in the formation of positive charge term. So that is as a whole H plus in the VB and free electron in the conduction bands. So these reactions which I have shown in this slide. And so this effect of foreign ion, that is the interference study. In our proposed study, the large number of various ions which I have added, and we found that there is no interference by addition of this much amount of the foreign ion and excipients along with our measurement of the fluorescence intensities are there. So this application part, I have collected some of the tablets from the market, and we tried to just find out whether the exact amount which will be found by our proposed method or not, and it will found have good recovery and RSD it is to be found. So just such type of the work we carried out in our lab, whatever the material which we synthesized it. So another point, another paper which I have quoted here. So just it is a quantum dots. It is just characterization. Then here, which we in this paper we have found. So here to perform this experiment for the detection of sulfides only. In earlier paper, the drug which we have analyzed. So in this case, so detection of sulfide by the quantum dots here. So actually it is a water soluble mercaptopropionic acids are there, functionalized cadmium sulfide quantum dots were synthesized. And this similarly, the spectra, colorimeter, fluorescence spectrophotometer, another quenching experiment, it is also it is to be valid and obeyed by performing the Stern-Omer equations are there. So simply this is also the same fluorescence, this is quenching. So colorimeter, it is a drastic change found in the another metals are there. So that is the DLS and other technique which we have compared the method for detection of sulfur by other reported methods are there. So just this is did for the water samples collected from the tap water, lake water nearby Rajaram Lake and Panchganga River, and by our proposed method. So sulfur which we found to be correct ones are there. So in just another things, we have the quantum dots and added the foreign ions. We have interacted with these quantum dots are there. And what from this slide which we have found, only cobalt sense to these quantum dots are there, and by easily which we can just say, so these the photograph images after 1 hour, after 1 days, after 5 days, I have checked these color, and so said it remains as it is. This photograph images are there, and it is simple. So only we found the cobalt which senses to the carbon dots are there. So with various concentration of cobalt ions are there. Very simple colorimetric experiments are there. And similarly, in corresponding the absorption spectrum which we have measured. So as by increasing this cobalt, you will find that. So this is increasing the absorbance. So it is just linearity and corresponding. So we have measured the fluorescence spectrums are there. So quantum dots, so fluorescence quenching spectra, in addition with the different amount of the cobalt ions are there. And here we proved, so that is to be determination of cobalt ions in water samples from different water sources, tap water, lake water, Panchaganga river, and we found it is correct ones are there. So just it is like this way. We use the fluorescence materials for it is a sensing technology, sensing purpose are there, medical application which also use here in this day. So in this another point which I have studied. So here we are synthesize sulfur quantum dots by simple carbonizations of the sucrose are there. So just simply we have taken sucrose in presence of this H2SO4, and by performing this mixture, we are getting the carbon dots solutions are there. So these carbon residues are there, and two applications which will be used to analyze the iron, and as well as it is a activated carbon adsorptions purpose. So we have just gone for the confirmation of the quantum dots, whatever we have synthesized in another way. So TAME, FTIR, that is the XRD. And then after confirmations, as usual, our study is fluorescence quenching study is there. So to just once the Stern-Omer equation obeyed, then our experiment fluorescence quenching, which is to be used. And this is the many parameters which will be used, the mechanism and analysis of the sensing purpose are there. So another my students have worked. So synthesize the quantum dots from waste tea residue. So in our kitchen available the waste tea residues are there, and waste tea residue, while we preparing the sugar tea in our houses, as you know, the sugar, it is a naturally source of carbon is there, and from that waste tea residue, so we have synthesized the carbon dots. It is also done some confirmation by various characterizations techniques are there, and then as usual we have did the fluorescence quenching experiment, found linearities are there, compare with the another reported papers are there, and it is really good or comparison with the recovery of other methods. So this is a very good applications are there. So just it is for metal sensing. We have in this and in pharmaceutical formulations we have proved from this. So such type of these various type of quantum dots we will synthesize and analyze its are there, analyze in various sensing technologies are there. So lastly,
Hello, sir. Sir, please, sound is not listening. तिथं काय झालं? हा. Streaming has stopped. No sound, no picture. Streaming has stopped now, so please correct. No,
Hello.
you are disconnected from the system. Hello, sir.
So how long time?
For a while, that's why I called you. Okay, be continue. Okay. नाडी सर ना फोन करून ठेव.
किती वेळ स्क्रीन दिसते सर? हॅलो.
हाँ दिसते सर दिसते.
दिसते sir.
Okay.
So here in this slide, whatever the quantum dots synthesized from the West T residue, so we applied to the fenugreek seeds, and we have soaked these seeds in the quantum dot solutions, and after that, so just we have checked his root length of the sprouted fenugreek seeds, and it indicate will observe that this increase the root length, which is actually directly depend upon the concentrations of the carbon dots are there. So we'll see some change. We use 10 microgram, 30 microgram in increasing the amount of the solution of quantum dots applied, and we have seen the change. The both actually this root as well as shoot length will see some change. Change are there. So this photograph images plant growth during 1 to 7 days, 10 days with different concentrations of carbon dot solutions are there. Now intention actually is to work that we know that we have in our sugar belt area people farmers are using the pesticides to yield much grow and maximum that are using, and it directly affect on our body. But in our the quantum dots, so we have seen there are there are the only source of sugars, and actually powders are there. From that, no any other hazardous chemical used for the quantum dots, and we are getting such type of the results. So such effects which will be seen in the agriculture field. So many other plant we have applied and used, and this actually work. I have filed for the patent, and as you know, so just it is on the stage of granted, but only waiting for the NBA approvals are there. So this is my applicable to the society works are there. So this is just whatever I work in my laboratory. It is just simple chemistry I use on to apply just metal sensing, pharmaceutical analysis, and also agriculture field. So that type of the applications I used to work in our department and in this chemistry with help of my collaborators from abroad and here in India also. So thank you very much.
Sorry, sir. Just a minute. Okay.
Hello.
Thank
you very much, sir, for your great knowledgeable and informative talk. From the desk of chairman of this session, I request to Professor Dr. Pore sir to interact with the participant. Professor Dr. Pore sir.
Professor Dr. Kolekar sir, I am very much thankful for giving a very nice, practical and collaborative information about fluorescent nanomaterial and their applications. Throughout your lecture, you have covered principles of fluorescence and well familiar diagram. We call it as a Jablonski diagram, in which photochemical excitation, photochemical relaxation is also there. And we are lucky enough that your lecture included general instrumentation, in which source of light, excitation with monochromator, single wavelength, then sample cell luminance at many wavelength, and also emission monochromator with one wavelength to the detector. So this general instrumentation method and information was very informative, and in addition to that, you continued your lecture with the characteristics of fluorescence, excitation, and emission of spectral profile. And in addition to that, you have added one more phenomena, that is fluorescence quenching. Actually, it is quite new for undergraduate teachers and students also. That is decreasing intensity of fluorescence. So, advantage of fluorescence spectra in continuation with your current research, semiconductor quantum dots, reported some your references from your publications with your research colleagues in your laboratory at our university, effect of pH value and buffer, calibration curve and detection limit of this method. Then mechanism of quenching, you have explained very well with giving examples of various drugs used during your practical exploitation. Then you have presented a very nice absorption spectra with the help of colorimeter, precision and accuracy, effect of interference, Then calibration curve and detection limit, mechanism of fluorescence quenching, applications of CDS, QDS for environmental analysis, for which our aim of the conference is there. Quantum dots, fluorescence enhancement study, carbon dots, quick and low cost synthesis of sulfur doped carbon dots, then sustainable carbon nanodots synthesized from kitchen derived from tea residue. So, as per the aims and objectives of our today's national conference, you have completed our objectives by giving a sustainable carbon nanodots synthesized from kitchen derived from tea residue. Our students and teachers are really impressed from your these practical experiments. Then fluorescence quenching experiments, nitrogen doped infrared spectrum, XRD pattern, and Raman spectrum. You have explained very well. Increasing seed germination, that is rate growth, should with photographs and field work done. You have shown with your research colleague. So it is a very impressive throughout your lecture. Effect of modified media on bird development after 15 days. Now it's in market. When we go to purchase the various vegetables, then we come across some questions that in minimum days, some people or farmers are getting such a vegetables. And one point from that we got from your lecture. With conclusion, fluorescence nanomaterial and their applications, and you have shown various collaboration under which you are working, and we from the place of the chairman of the session from our college Bharati Vidyapit, we hope you will immediately success in your patent file for the results of NAS. With this, I am very much thankful to you for accepting our invitation and delivering very nice talk on the topic as per the themes and aims and objectives of our conference. Thank you. Thank you very much.
Thank you very much, sir, for a
Thank you.
very good review of session first lecture. Now I would like to request to Dr. Kadam sir to express the great attitude of the session first. Dr. Kadam sir.
Yes, sir. Good afternoon, everyone. To the one and all present here, Honorable Chief Guest, Principal Dr. Mohan Rajmani sir, Honorable Dr. H.M. Kadam sir, Professor Dr. G.B. Kolekar sir, and in charge Principal Dr. Vivai Kadam sir, and all participants. It is such an honor for me to get opportunity to thank you all delegates. On behalf of our chemistry department, Matusri Bayabai Sripatrao Kadam Kanya Mahavidyalaya, I extend a warm welcome and thank to the people in gathering. I would like to express my gratitude to all esteemed delegates to express my gratitude for the webinar, for their presence and contribute to make their webinar a great success. A special thanks to Professor Dr. G.B. Kolekar sir for accepting our invitation and for a great session on fluorescent nanomaterial and their applications here with us today. Your thoughts have truly inspired us. Thank you, sir. I must thank the organizing team for working hard for the past few days to make the webinar successful. Thank you everyone once again for making the great success. More, sir.
Now,
thank you, sir. In
next
this way,
session will start immediately.
thank you, sir. In this way, we have over the session first of today's national conference. Now, respected all the participants, now we will start the session 2 of today's national conference. I handing over the charge of the session 2 to the chairman of the session 2, Honorable Dr. C. Patil, sir.
Good afternoon. Now I request Dr. U.K. Mohiti sir to introduce Latte sir.
Resource person.
Resource person. Moite sir.
I request to Dr. UK Moite sir, Head Department of Physics, to join and introduce the next resource person from session second, Dr. Sanjay Latte sir from Department of Physics, Vivekananda College, Kolhapur. Dr.
Can I audible to all?
Yes, sir. Yes, sir.
Thank you very much for giving me the opportunity to introduce the resource person, Dr. Sanjay Subhash Latte, which is just now working in Vivekananda College, Kolhapur as an associate professor. He is a native from Sangola, district Solapur, and he completed his BSc in 2005, MSc in 2007, and in short span of time, he completed his PhD in 2010. Specially, I suggest, mention here, his subject of research is silica-based hydraulic costing, which is very useful in industrial applications. He has many more scholarships. One more scholarships from UGC New Delhi. Second one is the Koch Vidyapit Turkey. Third one is the Korea Vidyapit Seoul. And Department of Science and Technology New Delhi, about 35 lakhs. India Science and Research Fellowship New Delhi, about 1.7 lakh. And National Natural Science Foundation of China, RS 20 lakhs. He has selected on national and international level committees, various national and international committees. For time being, I can't mention that committees here, but he has many research papers here, research contribution, with one more patent, Chinese patent, which is got in August 2019. He has international research papers about 55, national research papers about 16. The 4 books on his name, and he attended more than 40 national and international conferences. He is national and international MOU coordinator, especially in Tokyo University, Hina University, etc. He has organized one more international conference and one national conference, and he is awarded with various organizations. He is awarded with Eklavya Puraskar by Sangola Vidya Mandir and same Eklavya Puraskar by Shivaji Vidyapit Kolhapur, as he completed his whole education in Earn and Learn scheme. And he is also awarded with Kailaswasiya Bajirao Bhimrao Desai and Srimati Sonabai Bajirao Desai Award in 2005. He also awarded with D.Y. Patil Adarsh Shikshak Puraskar in 2019. So such typical and one of the researcher we got for this convention, national conference. So I request to Dr. Latte sir to give his informative talk in this national conference. Thank you very much.
Thank you so much, for a nice introduction. I hope my voice is reaching to you. And okay, I hope my PPTs are visible to all participants. Is it audible and visible to all the participants?
Yes, sir. Yes.
Yes, sir.
Okay. Okay. Thank you so much. I must thanks to Bharati Vidyapit. It's by Sri Sripatra Kadam Kanya Mahavidyalaya, Kaigaon, for arranging such a nice online national conference on applications of advanced physics and chemistry for development of science. My today's topic of presentation is oil or separation by superhydrophobic surfaces. Now, when I say this, just now I have joined Vivekananda College, Kolhapur. I worked in Rajaramra College, Jat, for around 6 years, and then I got transferred from Rajaramra College to Vivekananda College, Kolhapur. So my today's topic is oil water separation by superhydrophobic surfaces. Now, from where I got this inspiration for the current research. So in nature, there are many surfaces which show you some of the tremendous powers which are within them. One of the such a example is lotus leaf. So if you can see the lotus leaf, it is always clean, always green. Why it is always clean and green? Because if you put the water drop on the lotus leaf, the water drop acquires the spherical shape and it won't stay on the lotus leaf. It eventually roll off the surface. And if any dust particles on the lotus leaf, the rolling water drop take away those dust particles while rolling. So lotus leaf is one of the famous example in nature which shows the self-cleaning effect. It cleans its surface with itself. Now, might be heard that why this lotus leaf is extremely water repellent. Maybe from childhood, we could have heard that the lotus leaf has the layer of wax. So the wax is hydrophobic, water repellent. So that wax may help the lotus leaf to become extremely water repellent. Now, this was the understanding made by the researchers before the invention of scanning electron microscope. Of course, by optical microscope, you can't see the micro nanostructure of the lotus leaf. But when the scanning electron microscope was invented in the last decade of the 20th century, then of course, when you see about the lotus leaf, this lotus leaf has very importance in Asian culture. It is a symbol of purity, and many gods like to sit on the flower. So this is because it has the symbol of purity, self-cleaning properties. Now, as I'm saying that before the invention of scanning microscope, the people were saying that the lotus leaf might be having the thin layer of wax material, so it is water repellent. It was a half true, but in 1997, Professor William Bartlett, who is a German botanist, he observed the lotus leaf under the scanning electron microscope, and he captured this scanning electron microscope image. And what you can see that the lotus leaf contains microscale papillae, and each microscale papillae contains nanoscale crystalloids. And these nanoscale crystalloids are made up of wax material. So it is true that lotus leaf contains wax crystals, wax nanocrystals, but it also has the rough structure, microscopically rough structure, you can say. And in this structure, the nanoscopic air pockets can trap And these air pockets don't allow the water drop to sink or spread on the lotus leaf.
Participants' opinion.
So it is said that both microscale roughness and low surface leaf helps to show this hydrophobic properties. Now, what is super hydrophobic surface? Hydro means water, phobic means phobia, and surface means the surface which are afraid for the water. Okay, so which hits the water. So such a hydrophobic surfaces. Now there are different types of weighting found on the solid surface. The Young's model suggests that on the flat solid surface, smooth solid surface, the water drop can spread easily, having the contact angle less than 90 degree. Now, after Young's model, another scientist, Wengel, said that if you make the if you convert it into the rough solid surface, then it might help to improve the contact angle. So it was true. And when we roughen the smooth solid surface, then they found that the contact angle on such surface is increased and more than 90 degree. So such surfaces are known as hydrophobic surfaces, contact angle more than 90 degree. Now, in 1940, around 1940 to 50, the two scientists, Casey and Baxter, this tuned the way that the air pockets can be trapped inside the rough structure. Then highly tuned rough surface, the contact angle may go on more than 150 degree. So such surfaces are called as super hydrophobic surface. So it is a just differentiation between normal man and Superman. Okay, so like that. So additional powers. Now, how self-cleaning works? As I said on the lotus leaf, on normal glass surface, if the dirt particles are adhered, so the sliding water drop cannot take away all the dust particles. But on the superhydrophobic surface, where the contact angle is higher than 150 degree and sliding angle is less than 10 degree, if the dust particles are accumulated on such surfaces, the rolling water drop can take away all the dust particles. So it leaves behind the cleaned surface. Okay, so this is how the self-cleaning works on superhydrophobic surface. Now there are many ways to attain the superhydrophobic surface on variety of substrates for self-cleaning. You can use the nanocomposite of nanoparticles and polymer, and by different deposition techniques like deep spin, spray, simple methods, you can coat it on different substrates. Treatment, you can get the durable water repellent coating. Now, there are many industrial applications of self-cleaning superhydrophobic coatings, namely on the window and door glasses, body of vehicles, windshields of the vehicle, underwater cameras, fabrics, sport materials, anti-corrosive metals, traffic indicators, solar cell panels, which are frequently getting dirty, electronic materials, roadside convex mirrors, wood surface, and many. Now, what is my topic of interest is oil water separation using these superhydrophobic surfaces. So the key issue worldwide is the oil pollution. Like many big oil carrying containers when they collide with the icebergs, so the oil may spill on the surface of the water. Even in the industrial oil spill, it is the problem. So it affects on the marine environment. And to collect this oil, we have to use the nanotechnology where we can prepare the superhydrophobic surfaces for oil water separation. Now, there are many substrates used for the oil water separation to make them superhydrophobic and then used for oil water separation. One of the substrate is polyurethane sponges, which is very porous and have a polymer network like structure. And another substrate is stainless steel mesh. On this stainless steel mesh, you can the superhydrophobic material and you can use it for oil water separation. Now, when I was working in Rajaramra College, I didn't have the much funds. So what I thought to use a innovative ideas where I used sawdust particle as a nanoparticles. And I combined the sawdust particles with the different polymers like PMMA, polystyrene, like that. And my PhD and master students worked on it and we found very good result. So what we did is this first. So raw sawdust has many different types of the sawdust particles ranging from millimeter to micrometer size. So what we said that we have to filter lower size silica particles. And how to filter it? I have taken the 100 nanometer pore size of stainless steel mesh and the liquid solution of this raw sawdust was passed through this stainless steel mesh, which has the pore size of 100 nanometer. So whatever the sawdust particles we got it after filtration was less than 100 nanometer. So after drying, we mix this sawdust with polystyrene at different concentration and put it in the petri dish and put for overnight drying. After overnight drying, we got the pre-standing pellets and which was used for oil water separation, effective oil water separation. We could effectively separate the oil and water. Now, what are the experimental work? Okay, we made this sample coding SP1 to 4, polystyrene in chloroform concentration from 50, 75, 100, and 150. And sawdust concentration in polystyrene was kept 100 milligram per milliliter as a constant. Only the polystyrene, somebody has making annotation on the screen. So please avoid this one. Okay. So the photographs of the sawdust pellet. You can see the very thin few millimeter sized pellets, which are made up from the sawdust and polystyrene. And if you see the optical microscope images of all these pellets, then you can see that with increasing concentration of polystyrene, we can get the desired pellets with desired surface morphology, where the porous morphology, which was desired and which is desired for the oil water separation too. Okay, so you can see that on the sawdust pellet, you can see the water on sp2 sample, it is 130, and for the contact angle increase for sp3 sample like around 152 degree, but again it is decreased to 143 degree by increasing the concentration of polystyrene. Now, if you see the left side image, sorry, right side image, so if you put the oil drops, they are absorbing inside the sawdust pellets. So these pellets are repellent towards the water and absorbing the oil, so that we can use it for oil water separation. So the best sample is sp3 sample, where the polystyrene concentration was 100 milliliter, okay, in chloroform. So if you throw this sawdust pellet on the surface of the water, so it is floating. You can see the left side image, where in the beaker we have taken the water, and if you put the water drop, sawdust pellet, so it is floating. Now, there is again plastron layer concept, where the, as I said, on the superhydro, the air is trapped inside the pellets. So if you insert the pellet inside the water, you can see the shiny layer, the trapped air inside the pellets. Now, if you put the oil on it, so oil, the pellet, so it releases the water, the air bubbles. So you can see the air bubbles are releasing out from the pellets. Now, we use the tilting method for oil water separation, and we could successfully separate different oils like hexane. The coding is A, B, C, D. A in figure, you can see the hexane and water. So water was colored by different colors, okay, and the oils are of their own color. So in first, you can see that in figure A. So if you put the oil water mixture, slowly, hexane is separated out water mixture. So it is separated. So these superhydrophobic sawdust pellets are very useful for the oil water separation. Now, hexane is low viscous. Its viscosity is very low. If you take kerosene, gradually increasing viscosity of the oils from hexane, kerosene, diesel, coconut oil. So these oils also can effectively separated, completely separated through these superhydrophobic sawdust pellets. So this is the one of the cheapest way to separate the oil from the water. Okay. So this was the pictorial representation, and we have some quantitative data. So what is the separation efficiency? How much of the oil was separated through this sawdust pellet? So hexane, around 96% of the hexane was separated. Kerosene, it is also around 96. Diesel, around 95%. And coconut oil, it showed around 88% of separation efficiency, because it is highly viscous compared to hexane, kerosene, and diesel. And how much time these sawdust pellets can be used for the oil water separation? So if we use to separate hexane from the mixed order, to separate the hexane from the water, so you can use this sawdust pellet for around 40 times. 40 times you can separate mixed hexane from the water. And kerosene around 30%, diesel around 30 times, and coconut oil around 15 times. If you use to separate coconut oil to separate from water, only 15 times you can use this superhydrophobic sawdust pellets. Now we are working on it to improve this number of separation cycles. So it should be if you want to find the industrial applications of these sawdust superhydrophobic pellets, these superhydrophobic pellets must separate the oils for more than 1,000 or 2,000 separations. But still, it is one of the trial we have made in our laboratory. Now, sometimes the oil is mixed in the muddy water. So how to separate it? Now, these superhydrophobic stress pellets can separate the mixed oil like kerosene from the muddy water also. So you can see this from the A, B, C, D. Gradually, the kerosene was completely separated out from the muddy water also. So it is one of the important application. Now, these sawdust pellets can separate the oil from warm water also. Okay, warm water also. So this is another industrial application. This is another application. So some of the researchers have studied the separation of oil from hot water. So we also have studied the same, but here the for the stainless steel mesh, using stainless steel mesh, but for us also, for pellets also, it is showing the oil water separation from warm water, hot water. Now, you may ask, some of the participants may ask, so what is the durability of superhydrophobic pellets? Now, we used two methods to check the mechanical stability of the sawdust pellet. One is the adhesive test. You can see in the figure A and B. So you put the adhesive on the sawdust pellet completely, make it firm attachment, and if you peel it, so few of the composite of the sawdust and polystyrene may come with the adhesive tape, but it won't affect the original wettability, like superhydrophobicity of the sawdust pellet. Now there is another method, which is sandpaper abrasion test. So if you put the sandpaper on the pellet and if you put the weight on it and drag it on the surface, then you may see some of the scratches on the sawdust pellet. But again, it won't affect the superhydrophobicity of the pellets. So these pellets are durable in nature. It shows the durability. Now, with the knife, we have scratched some part of the few millimeter of the part from the pellet, and we surprised that, and we are also happy that even though it is not showing the superhydrophobicity at the top of the surface, but even you scratch it inside the pellet, it maintains water repellency, and it is, that's why it is showing the excellent oil water separation. So we are happy with this result. So conclusion, the first part, so we have another part, this one also. So the sawdust is abundantly and cheaply available in sawmills, so we can use it for oil water separation. So I'm not going to explain everything because I have explained it all in the past present slides. Okay, now we have used another way, another simple, another cheapest way to separate oil. So what we use, instead of using the stainless steel mesh, which is, because stainless steel mesh is very costly if you choose like 50 nanometer pore size or 100 nanometer pore size. So these stainless steel mesh are very expensive. So what we did is that we use the teak wood leaf mesh, which is dried. So it is also act as a mesh. So, and also of course it is free in nature. So the dried porous leaf mesh was coated with hydrophobic material and used for the oil water separation. So how we use it in mesh coated with superhydrophobic silica and polystyrene material on the porous mesh, and we found the crater-like superhydrophobic mesh, and it could effectively separate the oil from the water. Now, some of the experimental conditions. So we used 100 milligram per milliliter of solution in chloroform, and the coating solution was prepared for different quantity of the silicon particles in polystyrene, 10 to 30 and 40 milligram per milliliter, and applied on the leaf mesh, okay, by deep coating method. Deposition time is for 1 minute and dried for 50 degrees Celsius for 1 hour. So the leaf mesh which are coated for 20, 30 and 40 milligram per milliliter of silica in polystyrene were labeled as SPN, SPN2, SPN3, SPN4 samples respectively. Now, this is how the leaf mesh dry mesh is the porous, and we cut this porous part of the leaf mesh. And if you see the optical photograph in the photograph B, you see the network-like structure, mesh-like structure. And if you see it under the, then it is also confirmed that yes, it is very porous in nature. Of course, the pore size is around 100 to 150 micrometer to 200 micrometers. At left, and this is the SPN4 sample where around 40 milligram per milliliter of silicon particles in the polystyrene. This is the optical photographs. Now, when we studied it under the optical, as I shown you earlier slides, it is a porous nature. If you provide leaf mesh SPN4 sample, you can see the porous surface, and if you magnified it slowly, the same leaf mesh, you can see bottom two ACM images are of the same ACM images at the top right. Okay, so you can see that while magnifying it slowly, you can see it is highly porous and crater-like structure. So the oil may pass through this crater, which is beneficial for oil water separation. Now, this is the wettability of the leaf mesh. Okay, so the water drops are having spherical shape and having water contact angle higher, about 150 degree. So what setup we have done for the oil water separation? We taken two beakers. Top beaker, we put a small hole on it and put this leaf mesh, modified leaf mesh under it, and we have pasted it very carefully that only one of the liquid should pass through this leaf mesh without any leakage. Okay, so this is the setup for oil water separation. Now you can see that this is the setup, this is the modified leaf mesh, and the water contact angle when we measure it is the 162 degree, okay, on SPN4 sample. And if you put the oil drop on this sample, the oil drop quickly get absorbed on the leaf mesh. So oil is absorbed by this surface leaf mesh and water is repelled. So it is beneficial again for the oil water separation. Now, gravity based oil water separation. Now, in gravity based oil water separation, if you put both the mixture at a time, it is very difficult because the oil floats on the water surface. So there is no way to make contact between the oil and mesh, so that oil water separation cannot be done by gravity based. But if you put the the oil first and then water, then it can be like it can be said that it can be used for the oil water separation. So we use different viscosity oils like petrol, kerosene, diesel, coconut oil, lubricant oil for separation through this mesh, and we can see that it can effectively separate the oil through this superhydrophobic leaf mesh. Now, again, for the industrial application, to show the efficiency of this superhydrophobic leaf mesh, we use the tilt oil water for petrol, kerosene, diesel, coconut oil, and lubricant oil. And we could observe that all the oil was successfully passed through the mesh without allowing the water to pass through it. Okay, so it is separating the oil from the water. Now, again, some of the quantitative data: separation efficiency and reusability. How many times you can reuse this superhydrophobic mesh? So, for the petrol, around 98%, petrol, kerosene, and diesel around more than 96%, around 98%. But as the coconut oil has the viscosity, now I didn't put the how much viscous quantitative data of how much the viscosity of all the oils, but we reported in our published research article. So you can see that for highly viscous materials, these surfaces show less separation efficiency. For lubricant oil, it is around 80.
Hello.
Now, how is the separation ability? So number of cycles. So it can be used for petrol for 22%, kerosene and diesel for 20%, 20 times, coconut oil for 18 times, and lubricant oils for 4 times. And this is because of the viscosity. Lubricant oil is highly viscous in nature. So the conclusion of this is that a naturally available Tectona grandis leaf mesh was used for the oil water separation. A like superhydrophobic leaf mesh was fabricated by simple deposition of silica polystyrene and composite. So like other superhydrophobic materials prepared on commercially available stainless steel and copper, the as prepared superhydrophobic leaf mesh also exhibited excellent oil water separation efficiency, greater than 95%, and for more than 18 seconds. The use of superhydrophobic mesh provides high permeation fluxes towards the oils having viscosities in the range of 0.5 to 55 centipoise. Our present study will encourage the researcher to search out other stable leaf meshes available in Mother Nature. So it is asked to other researchers also to find out another leaf meshes which are highly stable than this Tectona grandis leaf mesh. The total cost of oil water separation process can be greatly reduced in near future novel approaches, and thereby provides an economically friendly solution. My acknowledgements for the Bharati Vidyapit's Sri Bayabai Sripatrao Kadam Kanya Mahavidyalaya, Kadega, Arts, Science and Commerce College, Kadega, which is affiliated to Shivaji University, Kolhapur, for giving me a very good opportunity to present my in this one-day national conference. Thank you so much. I have done with my presentation. Thank you so much.
Thank you very much, sir, for giving a very knowledgeable and informative talk. Now, from the desk of the chair of this session, I request Dr. C. Patel sir to interact with the participants.
Thank you, Dr. Sanjay Latti sir, giving a talk on oil water separation by super hydrophobic surfaces.
For hydrophobic.
Dust particles wash away with rolling
Surface.
water drops on the lotus
Super.
leaf. Such type the application of
Hydrophobic.
super hydrophobic surfaces are used for industrial applications, self-cleaning super hydrophobic surfaces. Such type of the applications, how the synthesize the such type of the pellets by using a sawdust particles as well as low sized silica particles, and the how to reduce the pollution from the water by separating oil from the water. Such type of the idea is explained very well by the Dr. Sanjay Latte sir, Department of Physics, Vivekanand College, Kolhapur. Different oil separated by method like hexane, kerosene, diesel, coconut oil separated from the water, as well as the completely separation is made with the help of the muddy water, oil from a muddy water, and they also inspired from the mesh for oil water separation. Setup of oil water separation is shown by the Dr. Latte sir. So such type of the great knowledge explained by the Latte sir, and I am very thankful to Dr. Sanjay Latte, Department of Physics, Vivekanand College, Kolhapur. Thank you.
Thank you, sir. Now, I would like to request Mr. Ingole sir, Professor in Physics and Convener in Criteria Evaluation, to express the attitude of the second session.
बर्फी दाखला धम्माचा मिळेल का विचार की 10वी पाचशे दाखले देत आहे का म्हणा या विचारून मग
Good afternoon to all. Hello. Honorable Dr. Latte sir and all participants in this conference. I would like to express vote of thanks to Dr. Latte sir. He accepted our invitation and given very nice information to all of us. Dr. Latte sir inspired from the picture, and he continued the research work. His journey in the field of making hydrophobic material, and along with that, not only hydrophobic, but super oil philic material he developed. I am very thankful to Dr. Latte sir for once again for sharing his research work. I also thankful to all participants for participate in this gathering. Thank you very much to all.
Thank you, sir. Now we are going to come to the ending, that is the validity program of the national conference. I would like to request the participant for participant opinion, Dr. Gautam Gaikwad sir, Assistant Professor, Department of Chemistry.
तुमचं नाव घेतलं होतं.
Dr. Gaikwad sir, please express your opinion regarding today's national conference.
Thank you, sir, for giving me the chance to express my views on this seminar. In first session, our teacher, my Guru G.B. Kolekar sir, have very nicely gave the information about the fluorescence and photochemistry and the research going on in his lab, as well as the importance of the photochemistry in the particularly with respect to the energy cells and as a solution of the energy crisis. Similarly, my another friend, Latte sir, also nicely give the nice information, and his research very interesting and enthusiastic research about the water and oil separation. And for that, I'm feeling very lucky to get the information about both these important topics, such as the energy related to the energy and water crisis. So I heartily congratulate the organizers, especially Bharati Vidyapita's Matosri Bhayabai Sripadrao Kadam Mahavidyalay's head of the department, Dr. Sanjay Pore sir, and his team, as well as the resource persons, G.B. Kolekar sir and Sanjay Latte sir, for their informative and enthusiastic talks on the current hot areas. Thank you. And also, I am thankful for getting a chance for here express my views on this conference. Thank you. Thank you, sir.
Thank you very much, sir, for your great opinion regarding our conference. Now, I would like to request the second participant to express the opinion, Dr. Dada Nade, sir, Head of Department of Physics, Dr. Patangarao Kadam Mahavidyalaya, Sangli. Dr. Nade, sir.
Thank you, More sir. Good afternoon all to all. First, I would like to congratulate to Dr. C. Patil sir, the convener of this conference, and More sir, co-convener of this conference. I really enjoyed this conference on online board, and I would like to mention here. First, sorry. Hello. Okay. Rajmane sir has given good information regarding the relation between the physics and chemistry, and then I learned about the I congratulate to the Latte sir. He has given very fundamental basic of the hydrophobic structure of the material and how they can be useful in the day-to-day application. So I congratulate to all the team members of this conference who are actively involved in this organizing this conference. For this conference, I say to thank you for giving
बोला
me
सर.
chance to give my views on this conference. I am very much thankful to the principal of this college, Bharati Vidyapeeth's Matusri Bayabai Kanya Mahavidyalaya, and all the team members. Thank you, one and all.
Thank you, sir. Now I would like to request another one participant to express their opinion. Dr. Amit Suple, sir, IQAC coordinator, Dr. Patangarao Kadam Mahavidyalaya, Sangi. Dr. Suple, sir. I would like to request Dr. Suple, sir, to express your opinion regarding today's national conference.
थांबा आता माझं व्याख्यान आहे लेक्चर आहे म्हणून ऑनलाईन आता एक 10 मिनिटं लागते 10-15 मिनिटं. हा आता मध्येच येऊन सगळं ऑनलाईन डिस्टर्ब. आणि हे बघ पोरे सरांना फोन केला होता आता पोरे सरांना फक्त काय काम आहे तेवढं विचारून मी डिस्टर्ब होतंय सगळं. हा पोरे सर.
Hello.
Hello sir. Pore sir.
After one opinion of the participant, you have to brief our participants from the desk of the president.
Okay.
Of overall activities.
Okay. Okay, sir. Okay.
Hello.
सरांना म्हणा आता हे झालं की बोलायचं आहे 2 मिनिटात बोलायचं. हा हॅलो वाक्य कसतरी थांबलोय आम्ही तुमच्यासाठी. हा
हॅलो.
हा सर.
हॅलो बोलू का कुणाचं आहे आता?
आता एक सुपले सर म्हणून आहेत पार्टिसिपेंट.
ते झालं
लगेच सर.
ओके सर. ओके.
I request to all participants, if somebody from you is interested to express his views, then he can unmute his speaker.
Okay, sir. Yes, I am audible.
Yes.
Good noon, everybody. I am here to share my conclusion about national conference conducted by Matosri Bayabai Sripatrao Kadam, Kanya Mahavidyalaya Kadegaon, on the topic application of advanced physics and chemistry to develop of science. Kanya Mahavidyalaya Kadegaon is a leading college in Shivaji University, Kolhapur. Get research activity. As compared to the rural area, this college is nicely conducted by Bharati Vidyapeeth staff of this college. So I greatly thankful to arrange such types of conference. Thank you very much.
Thank you, sir. Thank you, Gaikwad sir. I am very much thankful to you. At 11th hour, you have given your opinion, and we get the pleasure for your nice words. Then I request to Dr. Amol More sir to take the charge.
Thank you, sir. Now I would like to request to express the review of conference of today's conference. Dr. C. Patil sir, to express the review of conference.
Very good afternoon, everyone. Respected principal, vice principal, IQAC coordinator, and attendees. It is quite evident that a good company makes a long way seem shorter and takes us far. We achieved a quite fruitful and productive time in the company of such proficient speakers and very curious and enthusiastic attendees. I would like to appreciate and express my heartfelt gratitude to each and every member who contribute to make this conference a successful one. We all academicians and professors bear a responsibility of propagating and uplifting science and its applied branches. We are fortunate enough to be born to learn, teach, and live science. It was great to hear many new concepts, ideas, and facts. Each one of you, let us keep up the good job and exchange our knowledge and expertise with each other to help uplift our community and develop science. Needless to say, we today know the importance and feat of advanced physics, chemistry, and their applications. We need to explore it, experiment it, and assimilate it. Furthermore, to help the development of science, the quality of basic and theoretical science, both in terms of teaching and research, needs to be introspective, and proper measures should be taken in order to improve it. It is my great pleasure to mention and appreciate today's every event, beginning with the principal, Honorable Principal Dr. Rajmane Sir, SGM College, Karad, explained what is the relationship between the physics and chemistry. Also, the nanotechnology is a mixture of science applying the physics and chemistry to develop material science, how the applying quantum mechanics for development of science. Chemistry is essential for energy and the clean air. Also, chemicals are the new solution for health and industry. The chemistry is useful as a plant chemistry. Also, the how the medicines works, as well as the power tools for the ethics of development in science. Physics studies everything, natural phenomena and energy. Physics is now new tools, such type of the great knowledge given by the principal Dr. Rajmane sir. And once again, I am very much thankful to Principal Dr. Rajmane sir, SGM College, Karad. I am also thankful to resource person Professor J.B. Kolekar sir, Senior Professor Department of Chemistry, Shivaji University, Kolhapur. J.B. Kolekar sir has explained about the fluorescence nanomaterial and its applications, the types of luminescence, which depends on the mode of excitations. The luminescence is due to the mode of excitations, which is based on source of excitations. For example, the chemoluminescence, which is the chemical reaction which evolves the light. Also, J.B. Kolekar sir has very nicely explained the biological reaction which also emits the light. For example, firefly, which emits the light. Also, the J.B. Kolekar sir had very nicely explained the photoluminescence as well as the gives the examples of the luminescence materials like a rhodomine and nanomaterials, and gives the applications of the fluorescence just like a semiconductor quantum dots as a fluorescent group, carbon dots as a fluorescent group, how to synthesize carbon dots with a T residue. This is very useful knowledge for researchers, how the carbon dots are useful for growth of the crop. I am very much thankful to the Professor J.B. Kolekar sir giving a great knowledge. Now, I am very much thankful to Dr. Sanjay Lathe sir, Department of Physics, Vivekanand College, Kolhapur. Very nicely put forward the his talk with the title "Oil Water Separation by Super Hydrophobic Surfaces." I think Dr. Sanjay Lathe sir inspired from the nature, the lotus leaf self-cleaning property and dust particles wash away with the rolling water drops. So such type of the hydrophobic, super hydrophobic cleaning, how the self-cleaning works. Super hydrophobic surfaces are used for industrial applications, self-cleaning, as well as the cleaning of cars. So such type of the applications explained by the Sanjay Lathe sir very nicely, how to reduce the pollution by using a super hydrophobic surfaces. Uh, Sanjay Lathe sir had prepared with the help pellets with the help of a sawdust particles used for a nanoparticles, low size silica particles. So such type of the low cost sawdust particles are used to prepare a super hydrophobic pellets to separate the oil from the muddy water completely. So such type of the very great knowledge given by the scientist Sanjay Lathe sir. I am again very much thankful to Dr. Sanjay Lathe sir to giving or share this knowledge to our students as well as the researchers. Also, I am very thankful to our principal, Dr. Professor Dr. V.Y. Kadam sir. Thank you.
चला प्राचार्याने घ्या.
Thank you, sir. Now I would like to request for presidential address, Professor Dr. Bhivai Kadam, sir, in charge principal and head of the Department of Zoology. For presidential address.
Okay. ऐकू येते? Am I audible? Okay. Okay, sir. Okay, sir. Very good afternoon, everybody. Today, the Department of Physics, Department of Chemistry, and IQAC cell of our college has organized one-day national seminar conference on application of advanced physics and advanced chemistry for development of science. Physics is one of the most fundamental subject or discipline with main goal being to understand how the universe behaves. The advanced physics specialization builds on major in either physics or theoretical physics to provide broader and deeper mastery of physics. Advanced applications of fundamental principles of physics to solve broad range of sophisticated problems, including those likely to be encountered in a future career. Such problems may involve ambiguity and uncertainty and require the application of multiple principles. Advanced chemistry is the most important aspect of chemistry, including structure and state of matter, intermolecular forces, and reactions. Chemistry is the scientific study of properties and behavior of matter. Chemistry occupies an intermediate position between physics and biology. It's sometimes called the central science because it provides a foundation for understanding both basic and applied scientific disciplines. Today, we have a chief guest, dynamic, most efficient personality, Principal Dr. Mohan Rajmane sir. He enlightened the aim and objective of the conference and the applications of advanced chemistry for the development of science to build a nation, India. Again, today, we have two renowned scholars, resource persons. In first session, Professor Dr. G.B. Kolekar sir, Chairman of BOS in Chemistry, Department of Chemistry, Shivaji University, Kolhapur. He enlightened participants with the advanced applications of chemistry and on the topic principles of fluorescence and its significance, general instrumentation, characteristics of fluorescence, fluorescence conditioning mechanism, fluorescence nanoparticles, advantages of fluorescence spectroscopy, current research applications, reviews, application of fluorescent material, and principal parties fluorescence material. Sir, participants, our professor colleagues, really impressed by your lecture. The second scholar, resource person, Dr. Sanjay Latte sir, Department of Physics, Vivekananda College, Kolhapur. He also speak on the advanced application of advanced physics for the development of science on the subject oil water separation by hydrophobic surfaces. He explained the mechanism, the material which is used for the separation of oil and water. He also explained about pollution, that is due to the separation, the pollution is reduced. He explained very well. His topic is very innovative. So he's nicely explained the oil and water separation by super hydrophobic surfaces. Thank you, sir, for your nice information and innovative lecture. Thank you, sir.
Thank you, sir, for your valuable guidance. Now, lastly, I would like to request Dr. Sri Patil, sir, to express the gratitude of today's national conference. Dr. Sri Patil, sir.
A very good afternoon, everyone. It's my great pleasure to mention vote of thanks to each and every member contributed to make this conference successful one. First of all, I am very much thankful to Principal Dr. Rajmane sir, SGM College, Karad. I am also very much thankful to resource person Professor J.B. Kolekar sir, Senior Professor, Department of Chemistry, Shivaji University, Kolhapur. I am very much thankful to Professor Dr. Sanjay Lathi sir, Vivekanand College, Physics Department, Kolhapur. I am also thankful to our principal, Professor Dr. V.Y. Kadam sir, to make this conference successful. Now, I am also thankful to IQAC coordinator, Professor Dr. Sanjay Pore sir, to give the great guidance to how to conduct this conference. I am also thankful to our college vice principal, Professor Dr. V.S. Salunke sir, and all the committee members. I am thankful to our technical help given by our assistant librarian Dilip Deshmukh sir, as well as I am also thankful to the technical support given by the Professor Joy sir, as well as I am thankful to all the members, committee members who gives the contribution to the conference. Thank you very much.
Thank you, sir. On the permission of the chairman of today's national conference, we are going to over the conference.
Feedback link बद्दल सांगा.
Hello. All the participants requested that please feedback link of the today's conference will be sent after the completion of conference after some time. And please, all the participants requested to on the video to take a photo only. Please, all the participants requested to please on your videos, please. सर्व पार्टिसिपेंटला रिक्वेस्ट आहे आपला व्हिडिओ ऑन करा.
विषय पण छान होता सगळ्यांचे. होय छान
व्हिडिओ या तर तुला पार्टिसिपेंटला रिक्वेस्ट आहे सर्वांनी व्हिडिओ ऑन करा.
घ्या व्हिडिओ घ्या.
All participants are requested to on their videos to take a screenshot of other participants. ते हे कसं घ्यायचं? हा झालं की हो. हॅलो रामन ना घेतलं का? सगळ्यांना सांगा थँक्यू.
Thank you to all the participants. And in this way, we have here today's national conference. Thank you to all.
झालं.
चालेल का?
हा झाले झाले झाले. हो हो झाले. थँक्यू.
हो उठा. कॉन्फरन्सच्या पाठीमागचा फार मोठा माणूस ध्यान लावणारा. चहा द्या तुम्ही सर्वांना. जेवण